2024 A-Level Combined Mathematics Paper 2 Part B question number 11 Part B. Part A of the same question was discussed in a previous video. Link in the top right. Part B of this question has to do with relative velocity. The question says, three boats P, Q and R are moving in straight line paths with uniform speeds. At a certain instant, the boat Q is located 450 meters eastward of the boat P, and the boat R is located 200√3 meters north of the boat Q as shown in the figure. Now looking at the figure, we can see to go from boat P to boat Q, you have to go 450 meters in the eastward direction, and to go from boat Q to boat R, you have to go 200√3 meters in the northward direction. Now given this, they then say the boat P sails with the intention of meeting the boat Q, and the boat Q sails with the intention of meeting the boat R. Now what this means is that the velocity of the boat P relative to the boat Q will be in a straight line directly towards the boat Q, and similarly the velocity of the boat Q relative to the boat R will be in a straight line directly towards the boat R. Now given this, they also say it is given that the boat P meets the boat Q in 45 seconds and that the boat Q meets the boat R in 20 seconds. Now given this, they ask us, show that the speed of the boat P relative to the boat Q is 10 meters per second, and then find the distance between the boat P and the boat R at the instant when the boat Q meets the boat R. Now to start off with this question, let's consider the motions of P, Q and R. Now as I said, if boat P moves with the intention of meeting both Q in a straight line path with a constant speed, then the velocity of the boat P relative to the boat Q must be dead on in the direction of the vector going from the boat P to the boat Q. So therefore the velocity here must be in the eastward direction in a straight line like this. Now similarly, if the boat Q intends to reach the boat R, then the velocity of the boat Q relative to R must be in the direction of the vector going from the boat Q to the boat R, or vertically upward like this. So we have an eastward vector like this and northward vector like this. Now given this, we can also see the distance between P and Q in that same direction is equal to 450 meters, and the total amount of time taken for the boat P to reach the boat Q is equal to 45 seconds. According to that, since the velocity has the same direction as the distance here, we can say the velocity of P relative to Q will have the magnitude of the total distance of 450 meters divided by the total time of 45 seconds in that eastward direction. So simplify, we can see we get 45, or rather 450 divided by 45, which is going to cancel this and this, giving us 10. So we get 10 meters per second in the eastward direction. Now according to that, the velocity of the boat P relative to the boat Q is 10 meters per second in the rightward direction. So we can say something like the velocity of the boat P relative to Q is 10 meters per second in the eastward direction. Now the first thing they actually asked us was to show that the speed of the boat P relative to the boat Q is 10 meters per second. Now in this case, we found the velocity, but what they wanted was the speed, and therefore all you have to do is to drop the direction and just say the magnitude of the speed of the boat P relative to the boat Q. So we can conclude that here, if the velocity is 10 meters per second eastward, then the speed of P relative to Q is 10 meters per second. And with that, we are already done with the first part of the question. Now for the second part, where we take a look at the motion of P and R and find the distance between P and R at the instant when Q reaches R, we need to also find the velocity of Q relative to R. Now for that one, if we go down, we can see the velocity here is vertical upward, and this distance of 200 root 3 meters is also in the same exact direction. And we also know the total time taken for Q to reach R is 20 seconds. Now according to that, similar to what we did for both P and Q, we can say velocity of Q relative to R is equal to the total distance of 200 root 3 meters divided by the total time of 20 seconds in the vertically upward direction. And simplifying, we can see we get this 200 and this 20 cancelling, giving us 10 times root 3 or 10 root 3 meters per second in the vertical upward direction. And we can conclude from that the velocity of both Q relative to R is 10 root 3 meters per second in the northward direction. Now the reason these two needed to be found is because when we combine these two, we can get the velocity of the boat P relative to the boat R. We can do that by using the equation V P to R equals V P to Q plus V Q to R. And these two here are 10 meters per second in the eastward direction and 10 root 3 meters per second in the northward direction. So what we have is a system like this. We have 10 meters per second like this and 10 root 3 meters per second like this, which will combine to form a resultant velocity like this. So therefore what we're looking for here is V of P relative to R, and the two sides here are 10 meters per second, which is the V of P relative to Q in this direction, and vertical upward velocity of Q relative to R, which is equal to 10 root 3 meters per second. Now according to we can look at the velocity here. The final velocity of Vp to R can be found by finding its magnitude separately as magnitude of Vp to R as the length of this line right here, which is equal to the square root of the horizontal distance or 10 squared plus the vertical distance or 10 root 3 squared, which is equal to 100 plus 100 times 3 or 300 square rooted, which is equal to the square root of 400, which is equal to 20. So we have equal 20 meter per second. So the magnitude of velocity of P relative to R is equal to 20 meter per second. Now similarly, if we find the angle here, we can either find this angle or this angle, but I'd rather find this angle. And this angle, let's say theta, is going to be such that the tangent of theta is equal to the opposite, which is equal to 10 root 3, divided by the adjacent, which is equal to 10. So we have 10 root 3 divided by 10, which is equal to root 3. And from this we can see we get theta being equal to 60 degrees or pi by 3 radians, as theta is in between 0 and 90 degrees. Now with that, we have found the relative velocity of the boat P relative to the boat R, and can now use this information in order to find the path of motion of the boat P relative to the boat R. Now to do that, what I'm going to do is to go up and take this diagram here, copy it down, and then in this diagram, based on what I know, I am going to try and draw the path of the boat P as it travels relative to the boat R. Now considering the relative velocity, it has a direction of pi by 3 radians above the horizontal like this. Due to that, as the boat P moves relative to R, it will move in the same direction like this. So therefore the angle here will be pi by 3 radians, and this path here will be the path of motion of the boat P relative to the boat R, so relative to R. Now according to that, if we want to find the distance between P and R at the point when Q reaches R, we have to find the distance between some point on this line and the point R at the instant when the boat P is at that point and the boat Q reaches the point R. Now in the question they said the boat Q will reach R in 20 seconds. According to that, after 20 seconds of travel of the boat P along this path, we will have to find the distance between that point and the point R. Now here the velocity of the boat is in this direction 20 meters per second. However, if we look at how that velocity came to be, we can see it has a horizontal component of 10 meters per second and a vertical component of 10 root 3 meters per second. Due to that, we can break the velocity of this boat P into the horizontal direction and vertical direction and find the horizontal displacement and vertical displacement of the boat separately. Now doing so, we can see in 20 seconds, horizontally, our boat P has to move by 10 meters a second times 20 seconds or 200 meters. So therefore, the point at which we have to find the distance is going to be 200 meters eastward of the current position of the boat P. Now similarly, if we consider vertical movement, we can see vertically we have 10 root 3 meters a second times 20 seconds or 200 root 3 meters. So therefore, from the starting position of P, it will move upward by 200 root 3 meters. Now looking at the diagram, we can see since the boat R is 200 root 3 meters north of the current position of the boat P, after 20 seconds, if P moves vertically upward by that same distance of 200 root 3 meters, then at the point that we're interested in, the boats P and R will be at the same vertical position, and therefore the point we're interested in is this point right here. Now at this point, our boat P has moved vertically upward by a distance of 200 root 3 meters as we discussed, but horizontally it has moved a distance of 200 meters. So this distance here is 200 meters. Now according to that, we can also see, since the total distances here are rectilinear, if the total distance here is 450 meters and this distance is 200 meters, then this distance here must be equal to 450 minus 200 or 250 meters. So this distance here is equal to 250 meters. Now similarly, since what we have here is a rectangle where all of these angles are 90 degrees, the distance here must also be equal to 250 meters. Now according to that, we can see that the horizontal distance between the point of P at which we have Q meeting R and the boat R is equal to the total distance between P and R at that point, which is also equal to 250 meters. So the correct answer for the distance between the boats P and R, or rather actually P and R, at the point at which Q reaches R is equal to 250 meters. So going down for an argument for this, we can say when Q meets R in 20 seconds, P will be horizontal with R and the horizontal distance will be 450 meters minus the distance traveled of 200 meters equals 250 meters as seen in the diagram. Now from this we can finally conclude that the distance between P and R at the instant when P meets the point Q, or rather Q meets the point R, is going to be equal to 250 meters. So we can say therefore distance between P and R when Q meets R is 250 meters. And with that, we are done with this question. Now finally, let's go up and discuss the marks awarded for this question. So at the start of the question, when you find the velocity of p relative to q, when you take the magnitude as being 450 meters divided by 45 seconds and the direction is being rightward, each of these gets you 5 marks for a total of 10 marks. And after that, when you then find the final value of velocity of p relative to q and find that it's equal to 10 meters per second in the eastward direction, for getting this correct, you'll get another 5 marks. Now after this, in the question, since they ask for the speed of p relative to q and not the velocity, when you take the velocity, find the magnitude of the velocity as being equal to 10 and then say the speed of p relative to q is equal to 10 like this, saying this statement will get you another 5 marks. Now after that, when you consider velocity of q relative to r in the same way as you did for p to q and get the magnitude and direction correct, each of these gets you 5 marks for a total of 10 marks. And after that, when you simplify and get velocity of q relative to r as being equal to 10 root 3 meters per second in the upward direction, the northward direction like this, that gets you another 5 marks. Now from this, when you combine these two velocities to get the velocity of p relative to r like this, writing the equation correctly and combining them will get you 5 marks. Now after that, when you get this combined triangle, the resultant triangle, and find the magnitude and direction of the resultant, for finding the magnitude as being equal to 20 meters per second, you get 5 marks, and find the direction in whatever way as being this direction by either finding this angle as pi by 3 or this other angle as pi by 6 or something like that. When you find the direction correctly, you'll get another 5 marks. Now from this, when you then consider the path of the board P relative to the board Q, draw the path and then consider the geometry after 20 seconds like this. Drawing all of this correctly and finding the correct distance here will get you 10 total marks. Now from that, when you finally take this distance and conclude the distance between P and R when Q meets R is equal to 250 meters, you'll get a final 5 marks. And with that, we are done with this question. So I hope you enjoyed. If you have any feedback or questions, post them in the comments down below. Thank you for watching and goodbye.